Hey guys, these notes are for translating expressions and equations. Our essential question is, what is the difference between an expression and an equation? So we have two different types of scenarios here. We could have an expression or we could be writing an equation. So when do we do which? Well, with an expression, there is not an equal sign, but with an equation, there is an equal sign. And the key word about this is the equal at the beginning. It means equals. So you know that when you're asked to write an equation, you should have an equal sign somewhere in there. Whereas when you're asked to write an expression, you should not have an equal sign. So this lesson is basically being able to translate math into English and English into math. And so the first section and the majority of these notes are going from English to math. I apologize for pen tapping. My Apple Pen hits really hard on my screen, so it might sound a little bit loud. I also talk very fast. So if I talk too fast, you can always rewind or go back and rewatch it. I apologize. I just want to make sure that I get through these notes as efficiently as possible. So the first section of this is going to go over some vocab. And these are keywords we need to know in order to be able to translate sentences into math. So, add. There's some words that mean addition to me. Some things such as the sum, right? This is a word that we learn in elementary school, and they tell us that the sum is an answer to an addition problem. Another word that might mean addition is plus, or more than, right? If I have 5 more than Jonathan, right, then I have 5 plus whatever he has. So more than, some, plus, these are some things that mean addition to me. And there are other words out there, but these are just some of the key ones that are pretty important to us. Another word that actually also means addition is actually the word perimeter. And it's not a word that we think of when we think of addition, but if you think about it, when you're asked to find the perimeter of a shape, you're asked to add up all of the side lengths. So if I had a rectangle, right, if I had a rectangle, and I had the width of 2 and a length of 5, and they told me to find the perimeter, I would add up all the side lengths, and that would be the perimeter. So when you're finding the perimeter, you are adding. And so I just wanted to make sure that we understand that perimeter is an addition word. And remember that you're adding up the sides. So the key word in here is the rim. You're adding up the rim of the shape. So whatever that shape is, it could be some weird wonky looking shape, but if they give you all the side lengths, right, if they give you every single side length, then you add up the entire rim, the entire perimeter, and that would be your perimeter. You would add up the sides. All right, moving on to subtract. Some words that mean subtract are difference, right? Like, what's the difference between 5 and 2? Well, it's 3, because I take 5 minus 2. So the difference, less than, minus, fewer, deduct. There's lots of words that could mean subtract. I'm just naming a few here. Remaining. So again, there's lots of words out there, but I'm just naming a few. All right, next we have multiply. So some words that mean multiply to me are times, right? If I tell you to do 3 times 7, you know that you're going to multiply 3 and 7 together. So times is a multiplication word. Product is the answer to a multiplication problem, right? The product of 2 and 7 is 14. You multiply to get 14. Another word that's actually super important and we don't really think about it a ton, and it's only when it's used in specific scenarios, because technically you use the word of a lot, but there are some instances where of does mean multiply. When it says, I have 3 of that item, so I have 3 times that item. Of and per actually means multiply as well. So $5 per book, I would do 5 times however many books I have to figure out how much all of those books cost. And another word would be twice, actually. What does twice mean? If I have twice as many backpacks as you, which is kind of weird, twice as many backpacks, I would take your amount of backpacks and times that by 2. So twice also means multiply. And again, just like earlier, there are lots of words out there that mean multiply, but these are just some of the few that we talk about. And another word that also means multiply is the word area. So just like how addition is perimeter, area, we would multiply. If I had a rectangle and I asked you to find the area of it, you would take the width and you would multiply it by the length to find the area of that rectangle. So with area, you're always multiplying. With perimeter, you're always adding. And these are 2 very important words, especially when we move on into the very last week of our unit. So it's super important that you understand the difference between perimeter and area. All right, divide. Some words that mean divide are quotient. Oops. Quotient is an answer to a division problem. Also divided by, when it says something is divided by. 7 divided by 1 is 7. And then also half. If I have half of something, I could technically divide it by 2. So I can divide whatever I have. So I have half the number of cupcakes that you do. I would take your amount of cupcakes and I would divide it by 2. All right, and the last thing that we have here is the word equal. Now, there's some keywords here that, my Notability froze. Give me 1 second. I'm going to go ahead and close out of it and go back into it. There we go. Some words that mean equal to me. So these are very important, and it's going to indicate to you, hey, like these are the words that are telling me I need an equal sign. It tells me I want an equation. So is, right? Is an equals word. I say 5 plus 2 is 7, right? 5 plus 2 is 7. Is means equals. Is, was, are, results. Oops. The result of something, totals, in all can technically mean, it could technically mean equal, but it could also mean add, right? I have in all, I have all of this. I could be adding something together and it equals this amount. So it could be a lot of different things there, but those are some keywords for equals. And we want to make sure we remember these because we will use them for writing equations and such. All right, so we're going to start. Write an equation or an expression to represent the following. 2 more than a number. All right, now before we actually begin, I do want to mention that the key goal here is you want to dissect this piece by piece to make it as easy as possible for you. So 2 more than a number. So 2 obviously means the number 2. Now a key word that I see here is more than. And more than to me means addition. So 2 more than a number. Well, what's a number? Well, I don't know what that number is, right? They didn't tell us what that number was. And when we don't know something in math, we give it a variable. A variable is a letter. And so typically we like to use the letter X. You can use whatever letter you'd like. You can use M, you can use Z, but I like to use X. Now, before we actually move on, I do have a star next to this problem because there is an important note to note here. The word more than and less than are turnaround words. Now this is something that we forget a lot. And it's probably the reason why a lot of people miss number 2 a lot. So we'll go over number 2 and why it matters so much. With number 1, it doesn't really matter, but it's good to practice it because we see that there's a more than there. Anytime you see more than or less than, you want to think turnaround. Okay, so if I were to translate this, technically I have 2 plus x. 2 plus x, 2 more than a number. However, because more than is a turnaround word, it's going to take whatever was at the front and turn it around and put it at the back. So it's going to reverse the order of things. So instead of the 2 being at the front and the x being at the back, you're going to have an x at the front, and your 2 is going to be sent to the back because it's turning it around. So it's being turned around. Whoops. Now you're like, well, is there really a difference? Because isn't 5 plus 2 the same thing as 2 plus 5? Does it really matter the order for addition? No, not really. But it is good practice to see that if you have a more than or a less than word, to go ahead and turn it around. You want to turn it around. Okay, so let's practice with number 2. Now again, with number 1, addition, the order of things don't typically matter, but with subtraction, it does a lot. And I'll give you an example. If I do 10 minus 3 in my calculator, I'm going to get 7, right? But if I do 3 minus 10, am I going to get 7? I'm actually going to get negative 7. Same thing with different numbers. If I do 9 minus 4, I get 5. If I do 4 minus 9, I get negative 5. So the order here does matter because it does end up changing my sign of the number in the end. So when I see 3 less than a number, let me go ahead and move this a little bit higher. when I see 3 less than a number, I'm like, okay, well, I know that 3 means 3. And less than means subtract to me, right? Subtract, so the minus sign. And then a number. Well, I don't know what that number is, so I'm going to just call it x. So by instinct, I'm going to translate it exactly how it's seen. Most people would just be like, oh, 3 minus x. Final answer, I'm done. But that less than means I have a turnaround word, so I have to turn that 3 to the end. So that means my x would actually come first, my 3 would actually come to the back end, and I would still have a minus sign in between them. So you want to be very, very, very careful with this one. Okay, so it'll be x minus 3. I'm not sure why I changed the color on that. All right. Moving on to 3, the sum of a number and 6 is 14. Now here we have a new word, which is the word and. So I'm going to go ahead and do an important note here about and. And separates 2 parts of an expression or equation. Okay, so what does that mean? It means that they're being separated. There's 2 things that are being separated here, and we'll talk about how they're being separated in a second. So let's talk about the first keyword that I see. The first thing I see when I read this sentence is the word sum, and sum means to me addition. And then the next thing I see is a number, and I don't know what that number is, so I'm going to call it x. Then I see the word and, so it's separating x and something else, and the thing that it's separating is that number 6. And then I see is 14. No, it says is 14. So I'm like, what does is mean? Well, if I say 5 minus 2 is 3, is means equals. So remember that the is part means equals. So let's go ahead and put this all together. It's saying the sum of a number and 6 is 14. Well, if I were to just write down all the symbols that I just wrote, this is what I would have. Plus x 6 equals 14. And that doesn't really make any sense, right? It doesn't really make any sense. So let's translate and figure out what this is trying to tell us. Now, at the very beginning, we talked about how and separates 2 different things. It's separating a number, x, and 6, and it's separating them. Well, what's separating them? There has to be an operation in between, but what is that operation? Well, they tell you what that operation is at the very beginning of that sentence, and it's the sum part. So you actually have an addition sign that's separating the number and 6. And then you know that it's going to equal 14. It is 14. So let's talk about this. Let's break it down. The sum of a number and 6 is going to equal 14. So you're saying, hey, if I add 6 and a number, I'm going to end up with a number 14. So that's the whole big final translation for us here. And this was our first equation. And the reason why I knew I had an equation was because there was the is there. All right, moving on to number 4. The difference of twice a number and 16. Okay, the difference of twice a number and 16. Now again, I put it here, I put a star here as well, but we want to remember that and separates things into 2 parts. And separates 2 parts. Okay? So let's talk about the first keyword that we see. The first thing I see is the word difference. And difference means subtract to me, so the minus sign. The difference of twice a number and 16. Well, let's think about this. This is the first time I see twice a number. Well, I know twice means 2 times something, right? Like if I have twice as many as somebody else, this would be 2 times something. So 2 times. 2 times what? Well, it says 2 times a number, x. Twice a number. So essentially what I have here is 2x. 2 times whatever that number is, twice a number. If it said 3 times a number, then I would have 3x. If it said 16 times a number, I would have 16x. Okay? And then it separates and it has a 16 on the end here. So right here I have the difference of twice a number and 16. And there are no indicator words for me to see that there's any equal sign, so I shouldn't have an equal sign in this one at all. So I'm going to go ahead and separate what I have. So remember, the and separates my 2 parts. I know that I have 2x on one end, I have 2x on one end, and I have 16 on the other end. The and is telling me they're separated. So the 2x is on one side, the 16 is on the other side, but how are they separated? Remember, you want to look to the very beginning of that sentence and it'll tell you. It says the difference of these two things. Remember, difference means subtract. So the difference of twice a number and 16. So I'm taking the difference of this and 16. And again, there are no indicators that I have an equal sign, so this would be it. Moving on to number 5, the quotient of 25 and 3 times a number. Okay, well, the quotient. So quotient, what does quotient mean? Sorry, I just said quotient like 3 times. Quotient, remember, means division. It means divide to us, so we would see a division sign. It's saying the quotient of 25 and 3 times a number. Here we see and again, it's separating two different things. So there's going to be 25 and then something else. So the first thing I see is 25. So this would be just 25. And then it says 3 times a number. Okay? I want to do 3 times a number. Well, do I know what that number is? I have no idea, right? So I know number is going to be x. 3 times that. How do I say 3 times x? Well, then I would just write 3x. And here's what I mean by that. I have no idea what this number is, but let's pretend it's 6. What's 3 times that number? 18. Well, how'd you get that? You did 3 times 6. 3 times that number is 18. However, we don't know that it's 6. We have no idea what it is, so we put x there because we have no idea what that number is. But we know we still have to multiply it by 3, so it'd be 3x. So that's how we got the 3x there. Okay, so we're taking 25 and we're separating it. That and tells us we're separating it from 3x. So 25 and 3x. Well, how are they separated? They're separated by that division sign at the beginning. Now in math from now on, we're never going to use that division sign. There's another way we write division, and it's by using fractions. So we would really want to write it as 25 divided by 3x. This is how I would really want you to write it. Okay, we want to write it as a division. Technically, that first way is not wrong, but we don't typically ever use that division sign ever. And I will never use it again. All right, number 6. We're almost done with the second page, and we only got 1 page left, so we're almost 2/3 of the way there. All right, number 6. Twice the sum of a number and 7 totals to 18. Now, the thing that just popped out to me was that word totals to, and that indicates to me, hey, it's going to equal something at the very end. It totals up to something. So I want to go ahead and just kind of remember that, hey, this is going to have an equal sign in it. All right, now there is a star in this one because I do want to point out that, hey, there is something important. The very beginning of this starts with twice the sum. Okay? Anytime I see twice the or 3 times the, it indicates something to me. So twice the, and then whatever that word is, indicates parentheses. It means I need parentheses. So it could say twice the difference, twice the product, twice the quotient. But in this case, it says twice the sum. So it indicates to me that I need parentheses. So for a fact, I'm going to have parentheses. Now, obviously, I don't know anything else about it yet, right? But I do know it says twice. Now, what does twice mean to me? Well, twice means 2. If I have 2 times something. So there's going to be a 2 outside these parentheses. So twice the, which is the parentheses. And then it says sum. That is the next thing that I see here. Now, sum means addition. That means that I'm going to have addition in the middle of this because I'm going to be separating 2 different things. I'm separating a number and 7. A number and 7. So a number would be x and 7 would be separated by that sum. Now, how do I know they're separated? Remember that and means 2 things are being separated. A number and 7 are being separated because that and is telling me they're being separated by what operation? Sum, addition. And then I know lastly that it totals to 18. And I'm going to go ahead and move this down because it's kind of crammed. Totals to 18, remember that's going to mean equals 18. And that would be my final equation. Okay, so let's review this. Twice the sum. The reason why I know there's parentheses is because it's twice the blank, twice the sum. So I'm like, okay, there's going to be parentheses. Now, how do I know the 2 is at the front of those parentheses? Well, it says twice. If it didn't say twice and it said 3 times, then I put a 3 there. So it just depends on whatever that number is telling me to do. Now, the sum means addition, and that's why I have that inside my parentheses. If it said twice the difference, so let's practice this. Twice the difference. Because it says twice the, I know that I'm going to have parentheses for a fact. But the twice indicates to me that I have a 2 on the outside, and then the difference part means subtraction, which means I'll have a minus in the middle. So that's one way to think about it. So the sum's going to go in the middle, and the thing that it's separating is the number and then 7. All right, number 7, 3 less than twice the sum of a number and 5. Okay. Now, here's that tricky word again, and I don't know if you remembered it right when you read it, but it says less than there. 3 less than. Remember, what does less than mean to me? Less than means minus. It does. It does mean a minus sign, but it also is a turnaround word. And I'm actually going to change this so it's not the same color as the thing above it. Let's make it pink. Minus, and it's a turnaround word. So 3 less than came at the front of my sentence here, but that does not mean it comes at the front of my expression. It's going to go to the very, very back. So instead of saying 3 minus at the front, it's actually going to be minus 3 at the back, at the very back of my expression or equation, whatever it is. So 3 less than, you're going to turn it around. Okay? The next thing that I see is twice the. Twice the means parentheses, right? I have parentheses. Sorry, my husband is mowing the lawn, so if you hear some stuff in the background, that is what it is. All right, twice the. Now, I know that there's going to be a 2 on the outside of these parentheses because twice means 2. Now, what operation is going to go in the middle? Well, it says sum. Sum means addition. So I'm going to put a plus sign in the middle. And I'm separating 2 different things, and the 2 things I'm separating are a number, so x, and 5. Now, this one does not have an equal sign. There is nothing here that indicates to me that I have an equation. So it's just 2 times x plus 5 in the inside of the parentheses minus 3. Remember that minus 3 is at the back because you've turned it around. So it was at the front of your sentence. So a lot of people want to put this at the front, but you want to keep it at the back. And then twice the indicates parentheses, and a 2 on the outside because it says twice. Sum is addition, so it's going to go in the middle. And then you have a number and 5 being separated. All right, we are 2/3 of the way there. We're almost done. We're going to move on to translating math into English. So there's lots of ways actually to do this. When you're going from English to math, there's only really one correct way. But when you're going from math to English, when you have symbols and numbers and going into English, you can actually say it in many different ways. So I'm going to give you a couple of ways you can say some of these. So here I have 2x and then plus 3. Okay, well, I can't say 2x. How do I say x as English, right? I'd say a number. So I would say 2 times a number, right? 2 times a number. And then I could say plus 3. So I've translated this math into English. But there's also lots of other ways I could write this. Here's another way. For example, I could say 3 more than 2 times a number. And you're like, well, how's that? Why do you put the 3 more than at the front? Remember, more than is a turnaround word. So because it's at the back of this, I would actually write it at the front with the more than part. So if you ever want to use less than or more than, it's a little bit tricky. So I would try to stay away from those as much as possible, but that is another way you can write it. So let's go ahead and move on to number 2. So we have 3n squared minus 4 over here. So how would I write 3n squared as English? Well, I could say 3 times a number squared. Okay, 3 times a number squared. And then I could just put minus 4. Okay, Okay, -4. It works. That works fine. English makes sense to me. Okay, but is there another way I could write this? Probably. And I'll go ahead and give you another scenario just so you have like a couple different ways that you could think this. You could say 4 less than. So because I'm putting this at the front of my sentence, I'm saying it's at the back when I translate it to math. So 4 less than 3 times a number. Oops. Squared. So again, there's lots of ways we could write this. Now I'm going to go ahead and stop writing all the different types of ways so we can get through the notes. But number 3 is a little bit tricky. I am going to put a star next to this one because this one is important. Now let's go ahead and break this down, right? So the first thing I notice is, hey, I have parentheses here. How do I say I have parentheses in math? So remember earlier I said twice the sum, twice the difference, twice the quotient. That's when I know that I'm going to have parentheses. So the parentheses are going to be indicated by me saying twice the, okay? Now, the reason why I know it's twice is because that 2 is in the front. If it was a 4, I would say 4 times the. If it was a 3, I'd say 3 times the. But because it's 2, I could technically say 2 times, but I just want to say twice. So twice the blank. Well, what operation is inside there? A plus sign. So it would be twice the sum of what here? Well, twice the sum of, what are we separating? We're separating the 1 and the m. So that's going to be twice the sum of 1 and a number. And again, you can also write it as 2 times the sum of 1 and a number. Here's what you might say, but it's technically incorrect. 2 times 1 and a number, or 1 plus a number. Here's what's wrong with this. 2 times 1. Let's translate this to math. 2 times 1. All right, 2 times 1. Plus a number, plus x. So 2 times 1 is 2 plus x. Is that what I have up here? No, not even close, right? So you want to be very, very careful about how you write the English part of it, because English has lots of rules, so it can trip us up really easily. All right. Number 4, again, I'm sorry for any background noise. He is right now edging the sides, so that's why there's some noise. So if you hear that, I'm really sorry. All right, now here's a fraction. And remember with fractions, you always want to look at it part by part. You always look at the numerator first and then the denominator. So top and then the bottom. So the first thing I'm going to say is I see the x at the top. So that's going to be a number. Well, the next thing I see is the little division bar, this little bar right here. So a number divided by, and again, this is just one way to say this. There's lots of ways to say it, but I'm going to say it in this way because it's the easiest. So a number divided by, let's see, you could say 3 times a number. Oops. Three times a number, and then plus 5. And then another way you could say this, and I'm just going to write it all in pink. A number divided by the sum of 3 times a number and 5. So that is also another way. So I'm giving you lots of ways you could technically translate this. And then we have our last 3, which are write an equation for the following scenario. So it says to write an equation. So I know for a fact that all of these will have an equal sign somewhere in there. Okay, so start with number 1. A popcorn bucket cost $8 initially and 50 cents per refill. Johnny spent a total of $12.50. Okay, so let's talk about this. We know we have to write an equation. Now, probably there's going to be a variable in it, or x, because there's going to be something in there I don't know. And anytime we don't know something, we call it x. So let's go ahead and list out all the things that we do know. So what do we know? Well, we know a popcorn bucket costs $8 initially. We know that for a fact. It costs $8 initially. Okay, we know that. Oops, that's an ugly rectangle. Costs $8, so I know that I'm going to have $8 in here somewhere. $8. I also know that it is 50 cents per refill. Now, remember, per means something to me. It means multiply. So I want to have a little multiplication sign here. So I'm going to put a little dot per. And I don't like to use the X because it can get confusing when we have X as well. Times per refill. Well, I know the bucket costs $8, and I know it's 50 cents per refill. Here's the question. Do I know how many refills he got? I have no idea how many refills he got, actually. I have no idea. If I don't know the number of refills, that's my X. X is the number of refills. Now, this part is called defining your variable. I'm letting you know that X is the number of refills. Because when you're doing a word problem, it is very important for you to tell the reader, hey, this is what X means in this problem. It doesn't mean just any number, it means the number of refills, because we have no idea how many refills he purchased. Okay, so we know it's 50 cents per refill. So 50 cents, remember per means multiply, but I could just put an X next to it. Because in math, you don't have to write, if you want to say 3 times a number, so 3x, you don't have to write 3 times x. You can just write 3x. When numbers are right next, when a number and a variable are right next to each other like that, it is understood that they are being multiplied. So you do not have to write that dot in the middle. So 50 cents times each refill. And then I know he spent a total of $12.50. A total of $12.50, which means I have an equal sign here. Equals $12.50. Okay, well, is this my answer? It looks like I'm missing something, right? Doesn't make any sense. So I know it costs $8 for that popcorn bucket, and it's going to cost 50 cents for each of those refills. So how do I end up with a total of $12.50 then? Well, every time I get more refills, I'm paying additional money. So I'm going to have to add these two totals together. I'm going to add these totals together so I can get that total of $12.50. So, and 50 cents per refill is going to equal $12.50. $8 for the popcorn bucket and 50 cents per refill give me $12.50. Now, I made a mistake here on purpose, and I'm trying to figure out if you have noticed that mistake. I'm going to go ahead and box my answer, but there's something wrong with this. Here's the thing that's wrong. It's 50 cents per refill. Right now, I just have $50 per refill. So it's super important that you remember your cents here. It's 50 cents per refill. You don't want to put 50 because 50 means $50 right now. So you want to be very, very careful with that. All right, number 2. Sarah went to the fair and spent a third of her money on a ticket and half of her money on food. She spent $18 in all. So the easiest part for me is that I know she spent $18 in all. That means that at the very end, she spent $18. Equals $18. And that's easy for me. I know she spent $18 in all. Okay, so let's go ahead and break down from the very beginning. She went to the fair, and she spent a third of her money on the ticket. She spent a third of her money. Okay, so do I know how much money she brought? No. I have no idea how much money she brought. So that's what X is the money Sarah brought. We have no idea how much money Sarah brought with her. No idea. We just know that she spent $18, but she could have brought $100, she could have brought $50. We have no idea, right? So X is the thing that we don't know. We know that she spent a third of her money on it. So let's break this sentence back down. She spent a third of. What does of mean to me? It means multiply. So I know I have a third. Remember, we want to represent that the easiest way possible, which is going to be a fraction. So a third of, so I know I'm going to multiply something to a third. What am I going to multiply to it? Her money. Remember, I have no idea how much money she brought with her. No idea. So I know that I'm going to multiply it with X. So let's break that back down. A third of her money. I know that these two things are being multiplied because of means multiply. So a third times her money. We do not know how much money she brought. That is why there's an X there. Okay, so that's the first part. She spent a third of her money on that ticket. The next thing I know, so she spent more money. So it's separating two things. So we know that this is the next part of it. So I know this next part's going to go here. It's separating it completely. Okay, and she spent, oh, I can't use purple because I've already used purple. Let's use blue. She spent a half of, okay, half of means multiply, which means I'm going to multiply it to something. Half of her money. Well, her money, I still don't know how much money she brought, right? I have no idea. So her money is going to be X. I don't know how much money she brought, but I know she spent half of it. And the of means multiply, so I have a half times X. Half times her money. And they're being separated, but I know she spent a total of $18 in total. So she spent some money, and then she spent some more money. So that means if I added those two totals together, I should get $18, which means that they're going to be separated by an addition sign. Now this problem is super important and it stumps us a lot, so it's very important that you come back and you look at this one because you might see it again. So let's review this. It says that she spent a third of her money, because we don't know how much money she spent, and then she spent half of her money on food. So a third of her money on a ticket, half of her money on food, and in total she spends $18. So that's how we broke that down and translated everything. All right, last one. Macy ran 3 times as many miles as her sister. Together they ran 12 miles. Okay, well, I know for a fact that they ran 12 miles in total, right? Together they ran 12 miles. So I know in the end of my equation, I'm going to have it equal 12. Okay, well, we have 2 people here. Macy's running and then her sister's running. We have no idea how much they're running each, right? So Macy's running some and her sister's running some. So Macy and her sister. Okay, Macy's running something and her sister, but together they run that. So because it's saying that together that they ran that in total, together is going to tell me that they're going to be adding those 2 miles together to get that 12 miles. So I know together they're going to run and they're going to equal 12. The question is, how much should Macy run and how much should her sister run? Well, it says Macy ran 3 times as many miles as her sister. Well, do we know how many miles her sister ran? We have no idea how many miles her sister ran. So she's going to be X, the number of miles her sister ran. So it would be X. We don't know what that is. So X is the number of miles her sister ran. What do we know about Macy? We know that she ran 3 times as many miles. 3 times as many miles. So as her sister. So we know that she runs 3 times that amount. Her sister runs X, so if Macy runs 3 times that, it's going to be 3X. So our final equation here would be, let me write this down in a prettier color, 3X plus X equals 12. Macy runs 3 times as fast as her sister, right? So that's where the 3X comes from. Her sister runs X, because we don't know how much her sister runs, but together they equal 12 miles. So these word problems can be very confusing if you don't break it down piece by piece, so just make sure you take it a bit at a time. If you have any